Okay, thank you very much. All right, good afternoon. I've got a few things to share with you for this afternoon's class, which is back 6109, Green Sustainable Technology 1. This is not to say introductory course, okay? It's more like a recap of whatever you've learned previously, in your undergraduate studies with regard to building services, and plus the new stuff is all the green and sustainable design bits lah for your architecture, okay? So now I'll be presenting to you the Proforma first. Right? Let me just share the screen. Oh, before we get there, just a matter of attendance, all right? Have you tried opening your Spectrum? I hope you have. Right? Right now, you can see my Spectrum page for this particular class. Okay, right now it's not really well organized just yet. I'll be organizing all the lectures and whatnot over here. Hopefully by this afternoon. Okay, so you can access it with all the materials there. But in the meantime, you can see on the right hand side there's a QR code. Okay, this QR code here is for attendance, right? So for students, probably in your dashboard it looks a little bit different. It doesn't look like this. Okay, so you have to access the QR code here, the attendance link, and then you can click it yourself, right? So you can mark your own attendance every time we have a class. Okay, it only happens on the day that we have the class, right? At the time that we have the class. So if you're not around, you won't be able to okay. You can log into your Spectrum back 6109, and then you can do your own attendance later. But in the meantime, can Izati also record the attendance manually, on an Excel sheet or something like that? And then later on, you WhatsApp to me or email to me, all right? So that I can do cross-checking, right? Okay, so the attendance is very important. Okay, next one. Do you see what I'm showing right now? The alignment of learning outcome to assessment form. Can you see it?
Yeah. We're still seeing your Spectrum.
Okay, never mind. Do a new share. You see it now? Is it the alignment of learning outcome to assessment form?
Yes.
Yes, huh?
Yep.
Okay.
Yeah.
So this one here is really important, okay? This form here explains to you the learning outcomes. There are 3 of them here, 1, 2, and 3. Okay, on the left hand side, and then the levels of the learning outcome, and also the strategies, how it's being done, and also how it is assessed. Okay, and what is the achievement like, right? So for learning outcome number 1. Here, number 1 here, is PLO 1. 1 means knowledge, okay. 2 means practical, 5 means scientific, 6 and so on and so forth, okay. So for the strategy, okay, for learning outcome number 1 is pretty much just lecture, tutorial, assignment, okay. Number 2, lecture, tutorial, and presentation. Number 3 is the lecture, tutorial, and also the essay, okay. So for the assignment assessment method, okay, and the weightage, the conceptual diagram, this one I will update, okay? This one is not updated here. The conceptual diagram here is actually 30%, right? The verbal graphic presentation is only 10%. The remainder essay is 60%, right? And then in order for us to verify that you have achieved the learning outcome, at least 70% of you got a B, okay? 65% is a B, right? So if less than 70% of the students got a B, then we did not achieve this particular learning outcome. Therefore, we're gonna have to change the assessment method or the weightage, or perhaps the type, the way the assignment is being done, right? So that's one. And then in terms of learning time for all of you, there's a lot of hours here, 120 hours. Most of it will be done online plus your own time. So we've got lectures here, we've got lectures and tutorials. We also have some data collection. There's no individual work, yeah, it's all group work, right? And then the essay is also group work. And you also have your own time, which is the preparation for assignment and presentation, okay? Now this is the graphic presentation, which is just a presentation. There's no examination to this particular course, okay? So it's 100% continuous assessment, right? You can stop me anytime you want and ask me questions, okay? You don't just let me soldier on, okay? You can ask me questions in between. And then here comes the Proforma, okay, which shows you the syllabus. There are 3 learning outcomes here. The first one is determine the advantages and disadvantages of conventional and green building services. Okay, so you have to know both. Hopefully, you have enough information about the conventional building services, you know, like your lifts, everything else lah, okay, that you have learned previously. And then the second learning outcome is illustrate elements of green building services and building environmental control strategies to enhance the ability to design according to the concept of sustainability. Okay, so you need to learn a bit about green building design, okay, and you should be able to propose something, right? So later on, when you look at the assignment I'm going to present to you, right, you're going to have to do just that. And then last but not least, analyze the applicability of green building services and building environmental control. So you have to be able to assess it, assess a building and propose something, right? So that's the idea. That's a nutshell behind this particular class, right? Hopefully this course will enhance your ability in applying various green building technologies available and the ability to solve specific design problems, okay? By appropriate technical means, which covers the stuff below here. Okay, building physics, design, fire engineering, performance, design integration services, and other topics as well. Okay, so 100% continuous assessment, and then I will notify to you your marks online, okay, by WhatsApp or email or Telegram or whatever lah. Okay, right now we already have a WhatsApp group, so perhaps the grades later I'll put it through there. I just hope that everybody have registered. There are 48 of you in this particular class in the Spectrum page, so hopefully all 48 of you have registered properly lah. Please remember to confirm your registration. You have registered, of course, but you have to go back to my later on. Okay, I think within the next week or so, you have to confirm the registration. If you don't confirm the registration, the ASC will strike out your name, and even though you have paid for the course, but your registration will become null and void. You must confirm it. Okay, you better do that earlier rather than later. Okay. Any questions so far? No. Okay. So here's the important bit, right? This is what we call the course information form, right? In this form, it shows you some of the main references, right? Some books and online stuff that you can read. These are just some of the basic ones. You should be able to get even more online. I will also share with you in the Spectrum page, some literature that you can read, okay, with regard to a few things like MyCrest, like BSEEP, GBI, and a few other things as well, okay. And then I also put up into Spectrum, some links to some videos about green buildings, okay, that you can watch at your own time. Besides that, what is important here is the weekly schedule. So I've already updated this schedule. We should be working against it throughout the whole semester. I checked all the holiday. I think we only have 2 days which are on a holiday, So week number 10 here is on the Christmas day, and week number 11 days are gone. Basically, it kind of falls on a public holiday. You don't have to replace a class. That's the rule lah. So I'm not going to do any replacement class. I'll be expecting you to do the work at this because you do have a few other days throughout the whole of those 2 weeks. to do your work on the essay. Okay, so if you look carefully here, right, week number 1 lecture introduction. This is what I'm doing right now, and then after this, I'll be uh, lecture on if you have the time to the next. Okay. Then so next week after that, we'll be talking about grade building rating, okay, and programs such as lay down to you the many many other green building rating tools which are them. But what is important here for your assignment is green building index here. Okay, the green building index you're gonna have to learn even from now. You're gonna have to open up the website, read up. There's a wealth of knowledge there. There's a lot of information that you can download and learn about the rating tools that they have. Right. The one in particular you will probably need to know non-residential existing building. Okay. So then we have the mid-semester break on week number 6, and then in between week number 6 and 5, okay, week number 6 we have another lecture about IEQ in the quality, and then number 7 is about building automation system. Week number 8, 9, 10, 11, it's all about data collection, completing your coursework and essay. And then the coursework submission falls in week number 9, right? I'll show you what's the difference between the coursework and the essay. The essay is to be submitted in week number 13, which is next year, 15th of January 2021. And then on the same day, we'll probably have the presentation. Okay, so presentation will be done here on Zoom. It's a group work. So there are only 8 groups. We only have like 8 presentations, and hopefully every group too will take about 15 to 20 minutes each, right? Pertaining to your submissions, and also perhaps you on the stuff that you learn in this particular course can help you in your studio, the current semester and also the next semester. Because if you have not noticed yet, okay, if you look into the Proforma for both semesters, even for your design thesis later on, is somewhere there within it. So you have to learn quite a bit in this particular and also some other information at your own time in order to implement it in your studio. It's very important, right? So, any questions?
Probably not a question, tapi your voice got cut off at times, so it was a little bit hard for us to hear you. That's
okay. I'll try to make it louder. Ataupun I'll put on my microphone. Okay.
Can
you hear me?
Yeah, so I think it's not the volume of your voice, but it's the connection there.
Yeah,
because sometimes, yeah.
Internet connection, yeah, I know. Just now I was upstairs, but working from home, got kids. so,
okay.
So, they're upstairs. I'm not able to do it upstairs. Nanti kat atas tu, if I'm there, they'll come along and bother you. Okay. Right. I hope the internet connection is stable enough, right? Okay. before we move on to lecture number 1, can we do a quick introduction of all of you? I don't know most of you lah. Okay, I do know a few, but I do not know most of you. We already know that there's one international student here. Okay, so to get all 48 of you to ni a bit, it will take a long time. Okay. All right. Anybody? How many UM? Part 1. Nurin, how many UM graduates here?
And 23, thank you. There's 23 students, right? From UM.
Yeah, I can see.
I think 23 lah. Like from other batches as well.
Right, so nearly half of the class. Nearly half of the class. All right, cool. So from various batches, anybody who's joining straight from 3rd year here? I think there are a few of you guys joining straight from 3rd year, right? This year you got special dispensation from the Board of Architects, and they're allowing students without the 6-month working experience to come in. Okay. Yeah, it's going to be a bit challenging, but nevertheless, you should be able to do it. Okay. Anybody who's got more than 5 years of experience here? Ada tak? Anybody? More than 5 years of working experience. Anybody? I don't see anybody raising a hand. So, all of you are quite young lah, definitely. Okay. Which is all right. Good. Because, usually that 1 or 2 person with the 5 years of working experience will be relied upon on many things like Senk. It's a pity for that person lah. But nevertheless, yeah, all of you on level playing field. Okay. So, any UTM graduates here? UTM. You can speak out. UTM.
Yes, I'm from UTM.
Who's this?
Sunita.
Okay, good. Besides you, who else?
I don't think there's anyone else.
All right, cool. USM? Any USM graduates?
I'm from USM.
Okay, cool. Besides you, who else?
Me too.
Okay.
I'm from USM also.
Good. So we've got a few here. UIA? Any UIA graduates? None. Any UITM graduates?
I'm from UITM. For UITM, Sristana.
Okay, cool. Some more?
I think just 2.
All right, only 2. Okay, cool. UKM? Tak ada. UPM?
So I'm from UPM.
All right, cool.
So
I take
I'm
it
from UPM.
All right, cool. Okay. So I take it the rest are all from private universities, Okay. So UCSI, Taylor's, and so on and so forth, okay. All right, good. So we have a good mix of students here, but there's a big core of UM graduates here. Orpita, you're from which university in Bangladesh?
I'm from UTM.
Oh, you're from UTM. All right,
Yes.
cool. Okay, so you're technically a Malaysian graduate lah.
Yes.
Actually, a lot from UCSI too.
Okay. All right. Where you are, right? Where you graduated. Right now in this particular class or in this. So we've had students from private universities who did even better than private and then public universities throughout their MArch. So it's down to you. You have to learn as much as you can and try to do it as best as you can. And then also it doesn't matter how much amount of experience you have. 2 years, 1 year, less than a year, or none at all. It depends on your drive. Okay, your own drive. you should be able to do well, you know, if you're really motivated and really disciplined. Okay, 2 years is very long to do a masters by coursework. Usually masters by coursework runs for about a year plus. Okay, but 2 years is really long. So you have to be able to motivate yourself to get through it. Okay, and then you know the subject matter is very heavy as well. Design thesis, especially, you know, that I teach in year 2 is really heavy. So you know you have to be able to motivate yourself. Okay, enough with that. Let's go back to the lecture. Okay, can you see my screen right now? Can you see lecture 1 screen right now?
Yes, we can.
Okay, good. All right. This is just an introductory lecture. Yeah. Can you hear me? Oh, quite a few people are dropping out.
Yes.
Okay, what you can do now is to switch off your videos, okay, so that the you know, there's less amount of data flowing. Okay, you can switch off your videos and also try to mute yourself. Okay. All right. You can stop me at any time and ask me questions. Okay. Lecture number 1 is about building environmental systems and zero carbon buildings. Okay. So sustainability, there are 3 patterns to sustainability pretty much. Okay, so in theory, the experts, the people out there, and you know, the NGOs, they want it to be equitable. Okay, so it's equitable between social, the economy, the environment as well. You know? So everything sharing the same resources, everything having equal amount of rights, equal amount of access. Okay, and also focus. However, in reality, okay, the economy takes the cake. The economy is more important than anything. Okay, without the money, you won't be able to look after the people. You won't be able to look after their health. You won't be able to look after their welfare, and you won't be able to look after the condition of the environment as well. Okay, so you do need economic activity to generate income in order to get money to serve the society and also to look after the environment. Okay, that's the bottom line right now, and that's the reality. You know, in fact, this diagram here might not even be correct. You know, it should be even bigger than this, right? That's the reason why you do get a lot of people out there. You know, especially economists, industrialists. You know, they're not really. They don't really care so much about the social and the environment. Okay, what they do care is their bottom line, which is money, profit. And it's natural. Okay, so people out there, when they do businesses, when they manufacture something, what they want is definitely money at the end of the day. Okay, but however, we need to change this a little bit. We need to make sure that, you know, it's equitable. Even though the environment at the end of the day will probably be at the 3rd rank, you know, we need to improve. Okay, so at the end of the day, you know, this is the reality right now, you know, it's a Mickey Mouse thing, right? It's quite funny, it's a bit ironic, but that's what it is. But let's try to change this. Okay, so what is even better right now is to look at it from a different angle. So if you look at it from an environmental angle, and the environment encompasses everything. Okay, within the environment, you've got the people. You've got the people. If the environment is healthy, if the environment is clean, you should be able to have healthy people, happy people. Okay, therefore, you know, there'll be less amount of resources needed and funded by the state to provide, you know, good healthcare, to provide really good, you know, to get better health and well-being. Okay. At the same time, you know, by having really good environment, you know, it should be able to look after your economy as well. Okay, so your economy should be able to run really well. People are happy with it, and then, you know, even though yes, you do have a lot of restrictions in terms of not polluting the earth and so on and so forth, but at the same time, the economy should be buzzing still. You know, I give you an example. Okay, if you go to a country called Costa Rica, I don't know whether you've heard of the country. It's somewhere in the Central America. Okay, Costa Rica is a small country, tropical country, just like us, right? In terms of its development, perhaps we are more developed than Costa Rica. Having said that, about 100% of its energy that they use is derived from natural resources, renewable resources, okay, 100%. So they don't have coal power plants like what we have. They don't have diesel power plants like what we have, okay? They don't spew out all these noxious gases into the air like what we do, okay? Very clean, okay? Even though the country might still look very backward, but they have a very upfront, very advanced green technology economy going on right now. They recycle their waste. They look after the rivers. Their wetlands are beautiful and clean. Okay, a lot of tourists are coming along, even though there are lots of tourists, but nevertheless, the environment is still very beautiful and clean. Okay, and people are happy. The happiness index over there is a lot higher than anywhere else in the world, except for Bhutan. Kan? You know, Bhutan is the exception. Okay, because Bhutan is a very religious society. That is different. But in Costa Rica, because the environment is so beautiful and clean, people are really happy. Okay, and then people are healthy as well at the same time. Therefore, the state doesn't really have to provide so much amount of um, uh, healthcare system to cater for their needs. Okay, just enough. They're not a high income nation just yet. Okay, but they will be reaching there very soon if they look after this. And then, you know, they're also promoting green manufacturing, promoting, you know, a lot of green manufacturing, green construction, everything green, okay, just to look after the environment. Nevertheless, the economy still runs and it's doing well, okay, so they're not really suffering so much, you know, from the current economic crisis that we have right now. So if you look at angle, perhaps the environment will encompass everything, and you know everything else will fall into place, and people should be happy. Okay, so this is what we want, lah. But nevertheless, you should look. You should also need to look into providing for more people. Okay, so rather than just looking at single buildings and as architects, you know, designing singular green buildings, you need to be able to design a lot of green buildings or replicate your designs, or be able to design precincts or cities or towns which are complying to green building standards. Okay, this is to allow more people to enjoy it. Okay, more people to reap the benefits. Okay. At the same time, they should all be, you know, their health and well-being will increase. So another way of looking at things, you know, is to again, the ecology or the environment encompass everything. But nevertheless, you know, it starts with the people. The people is more important technically than the economy. So in terms of bioclimatic and ecological buildings, you know, there are a few kinds of buildings here, and this is based on what I've seen and what I've read. The four types are climate responsive buildings, intelligent buildings, green buildings, sustainable buildings. Okay, and then this is coincidentally it follows this timeline. A long time ago, you know, our buildings will probably be more climate responsive. For instance, you know, you are able to open windows, you're able to open the doors, there are screens, there are partitions with breathable materials, and then the materials are very light. Okay, the materials are natural. They allow ventilation to happen, and then they allow the building to absorb less amount of heat and release the heat very quickly as well. So the buildings are more climate responsive. So if you look at all the old buildings, they're pretty much like that anywhere in the world. Even if you go into a very extreme climate, for instance, in the extreme cold climate in the Arctic, okay, people build using ice. Okay, even though it's ice, the temperature difference between outside and inside is about 20 to 30 degrees. Okay, outside could be like minus 40, but inside the igloo, you know, it could be like, you know, minus 10 or minus 5, still very cold, but at least it's a lot warmer than being outside. Okay, and then, you know, it uses natural materials, so if it melts, you can easily replace it, right? And then at the same time, it becomes water at the end of the day. Okay, so it's natural material, is better for your skin, better for your health, right? Let's say if you go to an arid climate, let's say in the Middle East, okay, they use a lot of adobe. Okay, they use mud, they use you know, certain trees like the date palm to build their buildings. Okay, and then the materials are breathable. and the materials are natural as well. Okay, so in the tropical region like what we have here in Malaysia, you know, you will have the old Malay houses. Okay, so the old Malay houses are built out of timber. Okay, and then the roof is also built using thatch or you know, leaves, right? So everything is breathable, very light material. The amount thermal mass is very low, so it doesn't really absorb heat. It only reflects heat. Whereas, you know, in the Middle East, the adobe stone walls, and also the Eskimos ice walls of the igloo, you know, have got a better thermal mass. They will absorb all the heat and then you release it very slowly. So it's very climatic, very responsive as well. So there's design wisdom, you know, we should not lose them. Okay? So you have to remember the context where you live, where you work. You have to be able to design for that context. Okay. So in architectural theory kind of angle, it's called the gosh, I forgot the term already. Okay, but nevertheless, you know, it should be climate responsive, right? And then you can still apply it even today, even in modern buildings. Okay, sadly, in modern buildings, in modern houses, we use a lot of air conditioning. That's the reality right now. Okay, and then once you move on to, let's say, in the 1960s, okay, you start to see intelligent buildings. Right? Intelligent buildings are really big, tall buildings or complexes, which has got a certain amount of automation in them. When I say automation, means to say you don't just have a building shell. You also have some electronic systems in it, okay? So you will probably have some kind of monitors to look after certain systems. For instance, it looks after your fire system. For instance, the electronic system looks after your vertical transportation system, or your building automation system looks after the energy efficiency, you know, like sensors, for instance. You know, so some buildings have got sensors, even in the 1960s, to switch on and off your lights. Okay, so to a certain extent, that's what we call an intelligent building. So it's a 1960s thing, very old already by now. You need to move on from intelligent buildings, okay? But nevertheless, it's a good step in the right direction. And then, you know, any conventional building, when I say conventional, there are lots and lots of buildings around us, you know. And then many of these buildings do not have any automation system at all, okay? But you can easily turn it into an intelligent building by having sensors, by having some form of automation inside, okay? And then once you, and then this has developed further into green buildings. And green buildings started pretty much in 1980s and 90s. But even then, it does still look like an intelligent building, but they have started to put onto the building solar panels. They have started to put onto, to incorporate into the building some form of green construction. You know, they probably have some form of green structure as well. And then, you know, at the same time, they will probably have some manuals on how to operate the buildings, to look after energy efficiency, for instance. And then, you know, they will probably have some manual to tell the people how not to use the water in the building, okay, not to waste the water, for instance. And then beyond that, you know, in the 1990s, 2000s, until now, you probably get a lot of new architectural elements being added to the building to make it even greener, okay? So you have water-saving devices, you've got water-saving taps, shower heads, you've got sensors, you've got LED lights, you know, rather than incandescent lights. So this have developed over the last 10 or 15 years or so at a really fast pace, okay? And then now you're seeing a lot of incorporation of Internet of Things into buildings, okay? So you have the computer pretty much looking after everything into the building, in the building, okay? So you can control everything at your fingertip. You will probably have a tablet or a handphone, and you can control the electricity, the amount of lighting, the amount of ventilation, how cold your aircon is, you know, how hot or how warm your heater is, everything at your fingertips, okay? So 1980s, 90s, you've got components. Nowadays, you've got IoT in your buildings and easy controllability of your building, not just within your building, but from remote location, okay? So it's becoming really, really, really intelligent, okay? Having said that, you know, only one green building will not be sufficient. as I showed you earlier in the other diagram, you need a lot of green buildings to get everybody to have the benefit. Okay, so you probably need a group of sustainable buildings. When you talk about sustainable buildings, you've got a group of green buildings, but you also add to them a series of municipal or city-wide facilities. Okay, for instance, like solar panels for 10 or 15 buildings, not just individual buildings. Okay, so big solar panels. Perhaps all the walkways or the car parks are all covered with solar panels, right? So centrally done. And then perhaps you have a central facility for sewerage cleaning. Okay, so you have gray and black water recycling going on, and that is done centrally at one particular building. And this has happened in some locations in the world. Okay, I will share with you some information later on. So there are many other central facilities that you can have as well. Okay, and at the same time, when you have a group of green buildings, and in between you have a lot of landscaping, hardscape, softscape, which reduces the urban heat island effect, which increase the good ambience, okay, around your building, reduces the temperature around your building, allowing people to walk, that makes it more pleasant, isn't it? So a group of green buildings put together into a sustainable kind of community, that is what we need to target. That is what you have to do. Perhaps in the course of your career, it's really good if you can get involved in something like that, okay, rather than just one green building. So going back, the criteria here. Okay, so if you can look at the picture that I am showing you on the left hand side, is a building by Glenn Murcutt. This was done a long time ago, okay, but it's a modern contemporary version of a climate responsive building. But you can always just imagine the old traditional buildings. They are all climate responsive. People in the old days, they know they're not architects, but they were able to design for the context. Okay, so you're able to see buildings, houses on stilts. You're able to see houses, in the forests, houses in the mud, houses in the caves, like in Australia. And then you also see houses in caves in Turkey, so many, and also in America as well. The American Indians, some of them build houses inside caves. There are two things to it. One is for protection, of course, okay, but at the same time, it's a lot warmer or cooler inside the caves, depending upon the temperature outside. Even if it's searing hot outside, inside will be cooler. If it's really cold outside, it will be warmer inside. Okay, and then once you lit up a fire inside the cave, and that's it. You should be able to warm up yourself, kan? So this wisdom has been there all along for thousands and thousands of years. Okay, but some cultures are a lot younger than others. But nevertheless, all of them have got this similar trait. Okay, similar kind of character, whereby they were able to design for the context that they live in. Right. So, intelligent buildings, of course, a bit of controllability. You have some control panels here and there, sensors, like I mentioned earlier. Green buildings, you've got not just the mechanical, electrical components, but there are also some green building materials, for instance. You replace cement with fly ash, for instance. Okay, part of cement is replaced with fly ash. Part of cement can be replaced with rami, with cationic starch, with whatever lah, so that you can still get a similar kind of strength to the cement, but you reduce the amount of cement that you take out from the earth. Okay. The problem we have right now is that cement or concrete has the most ubiquitous building material on earth. Okay. Every country on earth will probably use cement. And cement has been used since the Romans, thousands of years already. Okay, the Pantheon in Rome is built using cement, and it's pretty much reinforced concrete, but it's a 2,500-year-old reinforced concrete structure. Okay, somehow or other, the knowledge of doing reinforced concrete to vanish in the Dark Ages. Okay, and then it came back. But if you look at sections of the Pantheon, which is still standing in Rome, it's actually reinforced concrete. But they reinforced it not just with metal, but they also reinforced it with some really organic materials like hay and whatnot. It's really interesting. And then even if you move on to the to the Gothic period, you would see a lot of natural materials inside their vaults. In their vaults, which actually look like concrete from below, it's actually made of natural materials. And inside them, you can see some hay, some timber, some wood, besides clay and cement and other things. Okay, so this technology has been around for a long time. Okay, except that it's just too ubiquitous right now. It's too widespread. There's a lot of clay being taken out from the earth that you cannot replace. There's a lot of steel being used right now that you cannot replace as well. The best thing now is to recycle all your steel, but there's still a lot of mining for steel going on all over the world. Okay, and it's non-renewable resource. Luckily for us, in buildings, there's a lot of aluminium. Aluminium mostly nowadays are recycled. Okay, so for green buildings, they can do some simple water recycling, rainwater harvesting as well. Okay, but for sustainable buildings, a bunch of green buildings put together into a community, okay, with community-wide facilities that will look after the whole community, which is the best solution. On the left-hand side here is the Sage 2, okay, the Council House number 2 in Melbourne. It's a really good building as an exemplar, okay. And then the other one down here is the BedZ development in London, which you can look up online. Okay, in terms of building criteria, according to the typology, you've got vernacular, bioclimatic, ecological, and okay, and there are two types of buildings here. Okay, for vernacular traditional buildings, of course, okay, climatically adaptable, built using local materials and done by local artisans. Okay, very sustainable. If you have to go back to this right now, fantastic, but it's something that is desirable. It's the ideal, but perhaps not the best solution, because right now volume is very important. Bigger buildings, more complex buildings, you can't simply just have simple artisans working on it. You need professionals working on it again. You need machines. So time has changed, right? And then there are also a lot of building materials which are imported. For instance, like here in Malaysia, most of our steel is imported. Okay, some of them are being recycled within the country, but most of the steel is being imported from overseas, right? Because we don't have our own. We do have some steel melting facilities in Malaysia, but they're not big enough to cater for the local market, right? And then similarly with aluminium, but luckily for aluminium, it's mostly recycled nowadays, even though we got everything from overseas. Glass is a problematic material. It's really important to protect the building. Okay, so when you see big tall buildings in Kuala Lumpur, for instance, there's a lot of glass on it. Glass comes from non-renewable resource, which is sand or silica, and sand is taken out from the river, right? And then you can't simply just crush a glass and put it there, right? So somehow or other, besides glass, if you can think of other materials to replace it, then wonderful. Okay, but until now, engineers are still working on it. So hopefully in the meantime, if you can concentrate on natural ventilation, for instance, you will not need glass at all. Okay. So this perhaps ring a few bells. Okay, I think your current project in studio is a short project, isn't it? It's all about lighting and ventilation, isn't it? Correct me if I'm wrong.
Yes.
What's your current project for the studio?
It's a low carbon office.
I think it's low carbon office, right? So I think it's an opportunity for you to really implement some of the knowledge that you've already gained from part 1. Okay, so try to apply some passive solar design into your building. Okay, and then look into some local materials as well if you can. And then you also have bioclimatic and ecological buildings. Bioclimatic buildings are climatically responsive. It can also be autonomous. Autonomous means that you have a community which is really far away from others, not connected to the electrical grid, okay, or not even connected to the sewerage and water grid. nowadays, even in Malaysia, almost all of the communities within Malaysia, on Peninsular Malaysia and also Sabah and Sarawak, are connected to the central infrastructure. You might still get some communities in Sabah and Sarawak which are disconnected away, but they will probably have their own energy generation. They will probably have their own water recycling. They will probably have their own rainwater harvesting and so on and so forth. Okay? Or they get water from the earth, or they get water from the mountains, right? So those communities which are disconnected from the main or central infrastructure, we can call them autonomous. Okay? Autonomous buildings, autonomous communities, right? They're self-sustaining and they're off the grid. And then you also have intelligent buildings, which I mentioned earlier. Mostly is intelligent building looking into thermal comfort, okay, and some active systems. Green buildings, you've got resource efficiency and also some new construction techniques, and the sustainable building, which also look after the welfare of many different kinds of many different facets of the society. The disabled, children, the elderly. You've got enough shading around your buildings, less amount of pollution, which is something that we want to aim for. Because right now, once you step out from the building, you can already smell the fumes from the cars and motorcycles, especially if you're right in the middle of the city. And then it's really, really noisy in the middle of the city as well. If you're away from the city center, it might not be really noisy. Okay. Having said that, at night, wherever you are, our night sky is always lit up, right? So it might not be that good. It might not be that good for some insects. At the same time, you're not able to see the stars. Okay. So there's too much more light pollution. But having said that, it's a necessity right now. Okay, street lighting necessity. So how can you reduce the amount of energy to do street lighting? You change it to LED, of course, right? So nowadays, new road lamps, you'll probably get LED lamps rather than the incandescent ones, right? So the infrastructure is also moving on, developing towards more efficient technology. Okay, what about features? Okay, for vernacular buildings, you can see windscopes, permeable envelope. I mentioned some screens earlier. Some of them are elevated above the ground, even buried in the ground. Like the ones in Australia. You go to Kalgoorlie, let's say, in Australia, or Coober PD, right in the middle of Australia. It's searing hot during the day, but once you go into the cavernous houses underground, right? It's really cold. It's nice and cool, and people can relax in it. Okay, so it's like 30 degrees difference, 40 degrees. So it's an event throughout history, okay. People have managed to do it. Okay, and then some of the materials can be heavy in terms of thermal mass. Can also be very light, like the wooden houses of Malaysia. Okay. And then for climate responsive buildings, you can get big operable windows, windows, screens, and then the roof will have to be heavy as well, okay, to protect it from the rain, protect it from the harsh sun, okay, or even the wind in Japan. And then autonomous buildings, for instance, the heavy masonry buildings in Sichuan province, they are self-contained. Okay, if you can remember the image of the rounded village, the building did not suffer amount of damage during the last big earthquake there in Sichuan, okay, because they're all freestanding. Intelligent buildings, you got sensors, light responsive material, phase change materials. Green buildings, you've got single building facilities for electricity generation, water recycling, so on and so forth. Sustainable buildings, you've got community-wide facilities, okay. So I keep on repeating myself, because I want to impress upon you that, these are the kinds of buildings, these are the types of elements that you can see, and then, they are different according to the scale of the building, okay. So if you're only worried about yourself, you can just go for vernacular buildings. Even though it's a modern contemporary building, but you implement in it all the vernacular building elements, right? But if you're more concerned about the community, you go on and build some sustainable buildings, okay? So what actually is the issue here, okay? The issue is just energy lah, technically, at the end of the day. For your information, we've already gone past the amount of carbon emission threshold, okay, for climate change to reverse. Now it's accelerating to a certain extent. I think we've gone past 560 or 600 parts per million, of carbon in the air, and that's really bad news. Okay, even though governments around the world have already claimed that they want to declare that they want to help by reducing the carbon emission, but they're quite clever. They always say carbon emission per capita. Okay? So even if they say like 30 or 40% reduction of carbon emission per capita based on 2000, the year 2000 data, it means that let's say in Malaysia we have about 30 million people. Okay, out of the 30 million people, only about 10% of the population will probably consume a huge amount of or produce a huge amount of carbon emission. How do you get carbon emission? By using electricity, of course, the most of it. Cars, by using a lot of cars, not taking the public transport. Perhaps using a lot of gadgets and things like that. Everybody does that. A very small percentage of the population will probably use even more so than others put together. Okay, and then when you say per capita, it means that you're dividing it up by 30 million. Okay, so it means that those people who are really polluting the earth will only have to reduce a small amount in comparison to others. So it's not very equitable. Okay, so the current calculation of per capita is perhaps a bit flawed, right? But nevertheless, if we can reduce the amount of carbon emission, is good lah. Might not be good enough, but it's good in the right direction. But right now, you can see that small population. If you have a vernacular buildings, a lot of vernacular buildings, you should be able to cater for small populations. Okay, but might not be comfortable enough as well. Okay, just imagine, if Malaysia was to develop using with all the vernacular buildings that we had previously. Okay, so you have a Kuala Lumpur filled with Malay traditional houses. What will that be? Might not be very comfortable at the end of the day. Okay, might not be very organized. Okay, we might not be able to clean it very well, right? And then at the same time might not be resource efficient as well. Okay, so and then
Maria, mana?
who's there? Could you please silent your okay. All right. So you need climate responsive buildings to look after more population. You need more intelligent buildings, and so on and so forth. Okay. So what is there to help along? You need regulations. You need programs by the government. You need good electricity tariffs. Okay. And then you also need a lot of other things to support that. Okay. So what about the holy grail, technically, the zero carbon buildings? This term has been bandied about a lot all around us. I did not classify it at all. Okay, there's a reason to it. Okay, zero carbon buildings actually can be achieved, but it's not very easy to achieve. Right now, you can only do it with a few things. Okay, you have to have on-site energy production. When I say energy, I mean to say you have to be able to produce electricity on the building, at the site of the building. And then you have to produce enough. I mean to say you have to produce about 80-90% of it on site. So a lot of solar panels, a lot of wind turbines and whatnot, in order just to generate enough amount of electricity. In order to reduce the amount of electricity needed for the building, you have to also incorporate a lot of energy efficiency measures. Okay. And then the on-site energy production and energy efficiency measures are actually to offset the amount of energy being taken out from the grid, okay, from the picture. And then, if possible, to produce more electricity and export it, okay, export the surplus to other buildings. For us here in Malaysia right now, TMB has got this net metering system going on. So let's say if you have a certain amount of solar panels on top of your roof of your house, and then on a certain month you probably produce more than what you need, the bill goes negative lah. Okay, so TMB will be paying you, rather than you pay them for the electricity that you use, they will pay you, okay, for the electricity that you produce, the extra electricity. So being net positive is something which is really desirable. Okay, not very easy to achieve, but something which is desirable. And then you have to be able to process the water consumption. Okay, process the water that you use, recycling it, and also offset the processed water that you consume from the main municipal pipes. Okay, so the water that you get from Shabas, let's say in Kuala Lumpur, if you can replace that with your own water that you harvest from the rain, let's say, or if you can replace all that water with water that you get from the earth, through a borehole well, let's say, then you should be able to offset that amount of water 100%. Okay. Or if you're able to use Shabas water and then recycle all the effluents, recycle all the grey water and the black water, that'd be even better. Okay, but that requires a lot of energy to accomplish, right? And then bottom line is, being a zero carbon building is being less dependent upon the existing city infrastructure, right? So you don't need the electricity from TMB, you don't need the water from Shabas, you also do not need enough water to process your effluents. And then you also have energy water efficiency, and then you can also convert waste into energy if possible. So it's not all mechanical systems. The people living inside the building will have to be very independent as well. They have to be very diligent. They have to be able to recycle their waste. They have to look after the way the lifestyle. Okay, the lifestyle is totally different, right? So there's a lot of these are the criteria, for zero carbon buildings, pretty much. So technically, you can take any building that you saw just now, a vernacular building, or even an intelligent building or a green building. You should be able to turn all of them, any one of them, into a zero carbon building, by applying any one of these at the top here. But it requires a lot more investment. Okay, so there's a lot more money there. There's a lot more effort from the occupants as well. So I'll give you one example here, right? This is the CH2 building, Council House 2 in Melbourne, completed quite a while ago, 2003. So it's nearly 20 years old now, okay? But it's still quite modern and performs really, really well, okay? It's highly efficient. It has got BIPV, which is Building Integrated Photovoltaic. And then it has got a low energy ventilation system. It doesn't have the air conditioning, you probably know. It also has got this heat recovery system with phase change material. This phase change material is becoming more popular nowadays, okay? Previously, it's really difficult to get phase change material, but even now in Malaysia, you can see some buildings which has got phase change material. This phase change material is just a chemical that sits in the equipment somewhere in your basement or perhaps in your roof. The idea is to absorb heat from the coolant you have circling around your system, okay? So this phase change material will do a lot of that work by not consuming energy at all, okay? So it will absorb the heat, it will dissipate the heat, but it doesn't require energy to be cooled down, like any other coolant. So it's really, really efficient, but unfortunately expensive, okay? But for this CH2 building, it's been there for the last 20 years, been working really well, no problems whatsoever, okay? In Malaysia, we do have phase change material. We've got it at, for instance, at the Malaysian Green Tech Corporation building in Bangi. We also have it at the Diamond building in Putrajaya and a few other buildings as well. Okay, and then a lot of the new offices springing up in Petaling Jaya here, which are rated GBI Platinum. They will probably have some phase change materials as well to help their cooling system in the building. And then, for this CH2 building, it also has got this cogeneration power plant. It has got a water mining facility. This water mining facility draws a lot of sewerage from neighboring buildings into the basement of this building, and filtering and recycling everything, making it clean before releasing that water back into the system. Some of the clean water is being channeled back into the buildings to be used as well. Okay, so it's a really good filtration system, something that you might see in Singapore a lot. Okay? In Singapore, most of the water that you drink from tap is actually recycled. Okay, when I say recycled, it's not water that comes out from your sink. It's water that comes out from everything, you know, from your sink, from your shower, from your toilets as well. Okay, so everything being recycled, purified, filtered, and then sent back to you as clean water that you can drink straight away without even boiling it. Okay, so that kind of technology is around nowadays, but it's really expensive. We don't have it here in Malaysia just yet. Okay, you might have really good filtration systems here and there. And in every homes nowadays, can you've got Kuku lah, Kowe, kan, you know, those are really good filtration systems. But you know, perhaps not as good as what you probably have running in Singapore, let's say, kan, you know. And then some of these systems will probably have UV treatment as well, or even ozone treatment, okay, to really kill all the bacteria. Okay, for instance, kan, you know, I saw on TV the other week, Zac Efron went to Paris and then met people from the Paris Water Authority. Okay, in Paris they've got hundreds of water fountains, okay, drinkable water fountains throughout the city of Paris. It's free of charge. People can go to the fountains, fill up the water, cold water. They can even fill up with warm water. They can even fill up with sparkling water. Okay, so they've got that as a municipal kind of facility throughout the whole city. And then the water that they drink were not boiled. Okay, they were just simply filtered and purified. Okay, and then cleaned with ozone. Right. So all that water, you know, you can rest assured that it's clean, no bacteria whatsoever. It doesn't have any we have a lot of lime in our water in Malaysia, kan? You know, we have a lot of what's the other term? We have lime. We've got we got a lot of lime in our water. So if let's say you go into a swimming pool here in Malaysia, kan, you know, you always get that aftertaste in your mouth, isn't it? That comes from our water. But in Paris, the water that they drink in a water fountain, which is free of charge, is treated with ozone. Okay, if you can imagine having that in Malaysia, that'd be wonderful, isn't it? But it's something expensive, lah. You know, people will have to pay for it. Okay? One day, perhaps we can have something like that. But you know, other cities, you know, in the world are having it already, right? So for this H2 building, it's been recycling, you know, filtering all the waste, 100,000 liters of toilet waste from the neighborhood and delivering back all the water to these buildings, right? And then, you know, if you can just look at the section here, kan, it's got the phase change material down here at the bottom. It's not a normal aircon system. This phase change material will cool down the water that's been circulated within the building. Okay, this office doesn't have aircon. It's got this thing which is what we call the what are the fins? Let me see. Okay, that one is in another lecture. I forgot the term already. It's actually a metal fin that is fitted to the underside of your ceiling. Okay, in the metal fin, you've got cold water running in it, and then the metal fin will absorb all the heat, right? And then it will absorb all the heat. The cold water within the system will become warmer, and then it falls down to the ground through a series of pipes, and then at the front of the building here, somewhere at the front of the building here, there's a series of plastic kind of big pipe here, and then over here the warm water is being sprayed. Okay, so if you remember your physics, water, when you spray, you change the physicality of water from liquid to vapor. It will lose energy. Okay, therefore in this particular pipe over here, a lot of heat is being lost. Okay, which is a really great idea because you've got this narrow alleyway here. even though this building, the front of this building is facing to another building, there's another building here, okay? So there's a narrow kind of alleyway here in front, and this narrow alleyway is being warmed up by all this heat coming out, permeating from this particular system. This is a really nice idea, okay? So once you spray the water, it loses heat, and then the sprayed water is collected again somewhere at the bottom here and being channeled into the phase change material down here, and then the water becomes cold and being pumped back again into the system, okay? And then excess heat within the building, okay, heat rises up, the heat is being absorbed by the fins, the chill fins here, and then the extra heat is being exhausted up through the chimney out at the back at the top of the building. Okay, so these chimneys are here without any power, without any motors at all. Okay, so they are being powered by wind. So the wind moves this, okay, and then all the hot air is being sucked out of the building at the back. Okay, so everything works together really well. The engineers, the architects looked at the building as a total system rather than just few components that you put together. So it's beautifully built building. The second one here is the Crossway House in the UK. This one has been built a long time ago, okay? But 2009, about 10 years ago. But nonetheless, it's very efficient. You've got a lot of solar panels in it, got biomass boilers and a few other things as well. It even has got some batteries inside it. Okay, nowadays Tesla has been promoting their batteries to be the best in the world. Technically, yes, Tesla batteries, not just for for cars, but also for buildings, are perhaps the best in the world right now. And many manufacturers around the world are racing to get something like what Tesla has done. Okay, so you can see some competitors, to Tesla. Might not be as successful as Tesla, okay, but nevertheless, yeah, that's the benchmark, the best battery that you can get. So you produce a lot of electricity from the solar panels, and then you store them into your batteries, rather than just exporting out straight away to the grid. Okay. And then you also have this BRE smart home, which is also built a long time ago, but it was refurbished in 2013. Okay, this is in the UK as well. Produces a lot of solar panels, and also produces a lot of energy for the solar panels. And then in the end, it becomes really efficient. But to me, what the benchmark is the BZ development in the UK, So whatever you have in this building, or perhaps in this building as well, you'll probably get totally in this development, and it does everything for you. Okay. At the end of the day, people live and work in this particular development. You've got houses, you've got small offices, you've got shops within it. So it's a complete development, mixed-use development with all the amenities for a green, sustainable community. If you move on to a much higher standard when it comes to energy efficiency, you will probably have to look into this particular building in Hong Kong called the ZCB building. 2012, but it produces a lot of electricity for its small size. Okay, 87 megawatt per hour. Okay? And then it should be able to reduce the carbon emissions by 7,100 tons per year, over 50 years. This is a huge amount of carbon emission reduction. And then it also has got this biodiesel tri-generation plant, right? So there's a lot of energy that can be exported out into the grid, for other buildings to use. And at the same time, it's called the ZCB, a zero carbon building, because it also has got this vegetable garden, okay, for the communities. You've got a lot of communities living around it, so they can come in, they can plant their own food, they can cultivate their own food, rear some chickens and whatnot here, and then they can reap some benefits from it. So the building produces electricity, and then the electricity is exported into the buildings around it. At the same time, the building houses some facilities for the community. So, for social sustainability, you've got the community coming here, interacting, talking to each other, looking after each other. There's even a kindergarten here, to look after the kids. So there's some social sustainability being looked at. The environment is being looked at, of course, but at the same time, it creates some economic benefits. You get surplus electricity, so cost saving. You get food, so cost savings here as well, So you see the economic model that I showed you earlier. If you look after the environment will look after you, socially and also economically. Closer to home, you have this academy in Singapore, which is the Building Construction Academy, BCA in Singapore, Building Construction Authority Academy in Singapore. This is an old building actually. It was refurbished and turned into the academy. It was completed in 2009. It produces a lot of energy. What is the best thing about this building? The sun shading, of course. Okay, you've got light shelves. You got light troughs to bring light deep into the building. You even have got some green facade. Okay, it's very innovative, right? So daylighting within the building is fantastic. There's less amount of artificial lights, right? So you don't have to rely too much on your artificial lights. You can simply just rely upon the light shelving and also light troughs that bring light into the building. Fantastic refurbishment of an existing building, which can be done on any other building for that matter. It just requires a lot of effort from the people, from the owner of the building, also designers and consultants, of course, right? In Malaysia, we've got a few buildings that we can look up to. First and foremost, perhaps the most recognizable, the Diamond Building, which is the Malaysian Energy Commission building in Putrajaya. Not a very big office. It's quite a small office, for that matter, not very big at all. But it was designed really well designed really well. And then the building energy index of this building is very low, which is 85 kilowatt hour per meter square per year, which is a really low number. For conventional offices, it will probably be around 200 to 300 kilowatt hour per meter square per year. It shows the amount of intensity or the usage of electricity within this building, which is quite low. It has got building integrated photovoltaic. It has got innovative lighting systems, very innovative energy efficient air conditioning as well. There's a mixture between a VRV and also a central air conditioning that is powered by a district cooling plant, which is not far away from this building. And then you get real-time data as well from the monitors within the building. You get to see how much more electricity that the building produces every day. You get to see how much water that is being used every day as well, and how much more electricity that is being used within the building as well every single day. Real-time data, which is really useful. And then once you step into this building, and it opens up to a really big and airy and bright atrium. Okay, and then there's a lot of innovative designs there that makes this building quite efficient in terms of energy. Okay, the predecessor to this building is actually this one here in Bangi, which is called the Green Tech Corporation or MGTC Zio building in Bangi. Having said that, the building energy index for this building is even lower. Okay, it's more efficient in terms of energy. It's about 65. That's the benchmark number that they have found out throughout the years of running this building. It's equivalent to running a big office but with a small house, with the energy consumption of a small house. Okay, it's like that. If you compare it to a car, let's say, nowadays you can get really luxurious big brand cars, like Mercedes, Mercedes C-Class running a 1.1 liter engine rather than a 2-liter engine. Okay, in the old days, when you see a Mercedes, it will probably be run by a 2-liter, 2.2 or 2.4 liter engine, or even 3-liter engine, which is really big engine. But nowadays, the Mercedes are run by really small engines, 1.1, 1.2, 1.3, even smaller than Proton engine, which is amazing. Okay, but more efficient, more energy efficient, quieter, less amount of consumption of fuel, less amount of carbon emission, right? And then that is the equivalent to buildings, right? So you've got a big building, but it runs on small amount of energy, which is fantastic. And to allow this to happen, they put up a lot of solar panels on the building, at this MGTC building. Okay. And then at this building as well, you've got phase change materials, you've got really deep recessed windows, and then there's no air conditioning. There is air conditioning. There's no air conditioning. You only use fans, but there's a underfloor cooling system that they have within this building and also this building that works to a certain extent to cool down the structure of the building. Okay, so you got some night cooling. Okay, and at the end of the day, you also have got rainwater harvesting to cater for the toilets as well. Really, really good showcase buildings, even in Malaysia, passing some international benchmarks here. Okay. So any questions? I've been talking all by myself for the past 1.5 hours or 2 hours. Any questions so far? Hello?
So far, no question.
Tak ada
Thank you.
Sure. So tak apa, it's just introduction, alright. I would like to give you a small take-home task lah, okay? Can all of you, between this week and next week, try to find out online, okay? Find out more about zero carbon buildings. Try to find out what is the definition of a zero carbon building, and then give me some examples of other ZCBs around the world, and then also the role of the people within the building. I'll put up this set of slides in Spectrum this afternoon, okay, and then you can use it as a reference. But I really need you to do this particular take-home task, okay? It's not graded, of course, but it's more for you to really expand your knowledge about it, okay? Any questions? Ada? Kalau tak ada,
okay.
Kalau tak ada tu tak apa. Other set of slides which is quite light lah for you to, but nevertheless it's important still. It's called building occupant behavior. I took this from TMB technically, okay. I don't know whether the set of slides are still there in TMB's website, but here goes. You can save a lot of energy, of course, right? I'm pretty sure a lot of you nowadays, because you live at home, you don't have to come to the university. Some of you don't even have to go to the office to work, so most of the time you're probably at home. Naturally lah, your electricity consumption and your water consumption at home will increase. There were lots of dissenting voices a couple of months ago, when they found out that the TMB bill has skyrocketed, double or even triple the amount that they usually pay for. But here's the funny thing. Just a sec, give me 1 second. Sorry, my baby was climbing up the staircase all by herself. Okay. People were really angry that they found out that their TMB bill was really expensive, but they should also realize that they were at home for most of that time, during the MCO, so naturally the electricity bill will rise, okay, especially if you use a lot of air conditioning, okay. On a normal day without the MCO, you'll probably spend about how many hours? 6 hours, 8 hours tops at your house. The remainder you'll be in your car, the remainder you'll be at the shops, the remainder you'll be at the office or at the university. So you will not be paying for electricity bill there, So your house's electricity bill will be low, okay? But suddenly it becomes high, right? But nevertheless, TMB and the government has been kind enough to let people pay in installments and then they give a lot of rebates, they give a lot of discounts here and there, which is great, okay? But it shouldn't continue that much because to me personally I think we have to pay for what we use okay? Because at the end of the day, TMB uses coal, uses diesel to burn, to give us electricity. Yes, they also have got a lot of hydroelectric dams, okay? They are also venturing into solar panels, but still a small amount of electricity is coming from that resource, okay? Those resources, most of it coming from coal. And where does the coal comes from? Australia. a few other countries as well. Okay, so we're paying a lot of money for that to be transported here, to be burnt into energy, and turn into electricity for our consumption. Okay, so it's a non-renewable source, right? So hopefully, in the next 10, 15, 20 years, the AMB should be able to really turn around their business, okay, and rely more on solar, let's say. Nowadays, you can see a lot of private companies opening up solar farms, okay. If you live in Kuantan, let's say, where you drive down the pantai Lebuh Raya Pantai Timur LPT kan, you get to see huge amount of solar panel farms kan, on the right hand side of the highway, okay. And then if let's say you go to KLIA, KLIA area pun there's a lot of solar farms there as well. Okay, there's so many solar farms propping up all over the place right now. It's a good thing. It seems like the industry is picking up, and they can see some money that can be made from it. But it will take a long time before we can be as good as Costa Rica lah. Okay, so challenging times ahead, nevertheless. Okay, so how do you save your energy bills? If you don't have aircon at home, you have to be a bit diligent. Open up the aircon, take out the filter, clean it yourself. It will do you wonders. Okay, not just to your electricity bill, but at the same time to your health. You feel sometimes you can the aircon becomes so dirty that you start to cough, you start to sneeze and things like that. But once you clean it, then the aircon will run even better, and then you can save electricity as well. Besides that, whenever you run your aircon, please close your windows, close your doors, close it. Okay. By sealing up your house, it will make your air conditioning system more efficient. So you don't have to really turn it down to a really cold temperature. All you need to do is just put some plastic strip under your door, okay, to keep all the coolness inside. And close the windows, okay. And then same time, change all the light bulbs lah, from your incandescent lah to your your old Kalimantan or fluorescent lights. Change all of them to LEDs. It makes perfect sense. It's cheap nowadays, and it's really cheap to run as well. Okay. And then if you are the person who does all the laundry at home, okay, all the ironing at home, it's best to iron a lot of clothes at one go, not just one or two pieces, and then you just leave your iron running for a certain amount of time, and you just lose all the heat and all the energy. Do a lot of ironing at one go. Well, you don't have to be so accurate like this person is, okay? But nevertheless, when you boil the water, just fill it up to the max and then boil it. If you just put 1 cup worth of water inside your kettle, it doesn't really worth that much more energy, effort. The energy needed to boil up that water is just the same. So fill it up, right, and then store it in thermos. And then, people love to open up their fridge, isn't it? When you are at home, I think you can easily count how many times you open the door of your fridge. It can range between 5 to 30 times per day. Try to do that experiment. Just look up for yourself. Calculate how many times you open up the fridge just to look for food. Whenever you feel peckish and hungry, every time you open up the fridge, the coolness will go out. You'll be wasting money, right? So if you can, try to limit it, okay? And then at the same time, use energy efficient appliances. Nowadays in Malaysia, we've got this rating system, okay? The star rating system, got 1, 2, 3, 4, 5 stars, okay? Even if you buy a 5-star energy rated system, you also need to look into the amount of energy that it uses per year. And then try to compare that between one fridge to another fridge. Let's say you try to buy a 250 liter fridge. Both 250 liter fridge will probably get a 5-star rating. But when you look at the amount of electricity that it uses per year, between the two, one will probably have a lower amount of energy consumption. Then buy that one. Okay. And then when you locate your fridge, it is best to locate your fridge in a very in a cool space. Okay. If you put it at a very hot location, the fridge will have to work really hard in order to cool down the coolant. So that will increase the amount of energy that it needs to run the fridge. Okay. I think a lot of people do this. Architects do this, right? Students do this, isn't it? You probably sleep in front of your computer, sleep on your drawings lah, whatever lah, Just try to remember to wake up and switch off before you go to sleep lah. Okay. Yes, you can argue that your laptop is energy efficient. It will sleep by itself, but even if it sleeps, it is still running on electricity. Okay. If it's just running on your batteries, then tak ada masalah, no problem there. Okay. Once it runs out of electricity or battery, it will die out immediately, right? But if it's connected to the wall, then perhaps switch it off lah. At your own houses, you probably have some spotlights. Okay. Use spotlights which are LEDs. Okay. In the old days, a spotlight will probably cost you 200 to 300 ringgit per piece, and then they are really bright. They use up a lot of electricity. But nowadays, you can buy really small spotlights for only 20 to 30 ringgit. Okay. But all LED, still very bright, but use up less amount of electricity, small fraction of the electricity for conventional spotlight. And then similarly within the house pun sometimes you don't really have to light up your house to make it really bright. Just make it enough for you to live in. There's a standard which is called the MS 1525 for energy efficiency for buildings. And then it stipulates the amount of lux that you need for many different kinds of spaces. The brightest spaces will be somewhere where you learn, let's say classroom spaces or office spaces. You probably need between 300 to 400 lux. But for bedrooms, you only need about 100 to 150 lux. It can be a bit dimmer. It doesn't have to be so bright. It can be a bit darker. If you can live in slightly darker spaces, then even better. But it doesn't mean that you just switch off everything. You still need to look after your health, the condition of your eyes and everything else. So try to have the right amount of brightness to your rooms. If you can open up the windows, let the daylight to come in, even better. And then it's a bit ironic, isn't it? Nowadays, you sleep in the aircon, you sleep in your room with the aircon on, and then you'll probably be underneath a really thick blanket. What if you turn up your aircon a bit, make it a bit warmer? You might not need the aircon so much. You might not need the blanket so much as well. Or just turn it off, or let it run on a timer, okay? So that it switches off at, let's say 2 in the morning or something like that. Okay. Similarly here set your aircon properly right? The government did put out a ruling that all government offices should be run at 24 degrees. Even at 24 degrees, some spaces might be a bit too cold. Okay, so try to make it suitable with your surroundings. Yeah, use spotlights you can, but put sensors on it. Okay. If you love fish, you've got aquariums. You need to really service your pumps regularly, okay? Because the pumps get dirty. Once the pumps get dirty, you need more energy to pump the water. Okay, so clean it up, clean out the tanks, clean out the water as well. It's not just good for your electricity, but it's also good for your fish. Okay, your fish will live longer. Some people love to really cram their fridge with stuff. Okay, you get two kinds of households. Households with fridges which are empty, perhaps like mine. But there are other households which are crammed full of stuff in the fridge. Okay, it might not be full in the fridge, it could also be full in the freezer above it. Okay, so you just need to put enough amount of stuff inside it. Don't cremate with a lot of stuff, because if you do, then you know there's a lot more energy that you need in order to cool things down, right? Yeah, clean up your electrical appliances lah once in a while. Okay, if you can clean up your kettle, even better lah, you know, because kettle tu kan you can get a lot of residue kan, you know, at the bottom of your kettle kan. If you can clean them up, great. If you can't, it's okay, just replace it altogether. Hot water shower kan. This is the irony again. Okay, you sleep in the aircon, you have really thick clothing, really thick blankets and whatnot. At the same time, you know, in the morning because it's too cold, you have to take warm water shower kan. Whereas you know the cold water is actually better for your health. You know, it wakes you up, right? So if you can, try to reduce the amount of hot water shower lah. You know. The dryer, okay, the cold wash, just use cold wash. You know, you don't have to really go use hot water wash for your clothes. It doesn't make any much difference, pun, you know. Just wash your clothes with cold water, okay. Again, air conditioning, you know, use the right kind of air conditioning for the right kind of space, lah, okay. If you have a really large space, then you can go for something with more horsepower, you know. But if you have a small room, you don't need to go 3, 4, 10 horsepower for that matter, kan, you know. Try to size it properly lah. Most of the time, the technicians and engineers will probably quote you with the right kind of size, okay. So try to follow it lah, okay. So at the end of the day, you know, everything has got cost to it. It's got the certain amount of power, power rating to it, okay. So some items use more electricity than others, okay. This is just an indicative lah, okay, indication. There are other numbers around online that you can also look at. But nevertheless, you know, you would know for sure that there are certain items, you know, let's say the washing machine, not just a washing machine, perhaps the dryer. You know, nowadays there's a lot of dryers at home, you know, the dryer uses up a lot of electricity. So you know, if you can fill it up with a lot more clothes, you know, just enough for it to run, then better. Don't just dry like 2 or 3 pieces of clothing, okay. It's a waste of energy for sure. The other one is definitely the air conditioning. You know, the air conditioning uses a lot of electricity. You know, we cannot run away from it. You know, we need it nowadays. You know, it's almost a necessity, more so than a fan. But you know, if you can reduce the amount of hours that you use, you know, perhaps increase the temperature a bit, and then you know, use it in tandem with a ceiling fan, that will be even better. And then seal up all your doors and windows, of course, you know, so that you don't lose all that coolness, right? And then you know, if you can invest a little bit, you know, why not invest in insulating your home? Insulate your walls, insulate your roof. You know, that will keep all the coolness inside, all the hot weather outside. Okay, be, you know, a good thing to do, in fact. So yeah, can you practice all of this? You know, try to make yourself better, and hopefully, you know, reduce the amount of electricity that you use. That will be good, not just for you, but for the community and also the environment, you know, in general. Okay, I think that's enough for today. We are approaching 5 o'clock. Any questions? Anything that you want to discuss about?
I have a question, not to say question, maybe like some kind of like a discussion, because this was something that we talked about yesterday on zero carbon buildings and also GBI rating. So are zero carbon buildings automatically GBI rated? Like how does it work in that way? Okay,
it's not automatically rated lah, right? Technically, GBI ni kan, the Green Building Index, is a rating system. It's a voluntary rating system. You have to pay for it, okay? So any building out there who wants to be rated by GBI, either certified ke, you know, silver, gold, platinum, so on and so forth, kan, okay? In order to get all those rating, to brand your building, you have to comply with the standards, okay? So within GBI, there's a certain amount of standards. There's 6 different kinds of indicator groups, right? You've got energy efficiency, you've got water efficiency, you've got a few other things as well, right? So you have to employ a GBI facilitator, okay? No, a GBI evaluator, assessor. No, facilitator, GBI facilitator, to help your design team, to help your architect, your engineers, and so on, to design buildings which comply with GBI's standard, right? So there's some simulations that you might have to do. There are some calculations that you might have to do, okay? And then you have to probably incorporate some architectural elements, right, to comply with GBI standards. And then you might even have to do some manuals, let's say, okay? All this is instituted within GBI, okay? And GBI is not the only one, okay? You go to Singapore, you've got Green Mark. You go to Australia, you've got Green Star, you've got Neighbours, you've got a few other things as well. You go to the UK, you get probably one of the oldest one, which is oh gosh, I forgot the name already. If you go to America, you've got the American one, okay. So there are many different kinds of rating tools all over the world, including CASB, from Japan. All the rating tools are for one thing, which is to ensure that how green is your green building, technically, okay. So it doesn't rate zero carbon building. You can enter a zero carbon building. You can get a zero carbon building to be rated with GBI. At the end of the day, that zero carbon building might be a platinum building. It could also just be a silver building because it might not be able to comply with sustainable site indicators within GBI for that matter, okay? Because zero carbon buildings mostly is all about energy, about carbon emission, okay? But energy and carbon emission is only covered by about 50 to about 60% of GBI alone. The remainder is everything else, okay? So you get marks from somewhere else. So not necessarily a zero carbon building can be a platinum GBI building. You get what I mean? So what you need to do is simply just try to rate the building and find out, what it can achieve at the end of the day. So if you can improve on certain things, then you can try to improve. I give you an example, okay? In GBI, you've got this indicator group called Sustainable Site and Management, something like that, okay? So in sustainable sites, you get a lot of points. The building will get a lot of points by being close to the public transport, let's say. Or if the building has got covered walkway towards the public transport, let's say. Okay. Even though that building is a zero carbon building, but if it's an autonomous zero carbon building sitting somewhere in the kampong, let's say, you will not get any marks at all for that, isn't it? So you'll be wasting a lot of marks, and even though it's a zero carbon building, you will not be able to get platinum GBI. You understand what I mean? So that happens lah. So continuously, you will probably see some really, really good green buildings that follows a lot of green building benchmarks, but they can't score high in some of these rating programs. Okay, it's unfortunate, but that's what it is lah. Because the rating programs are meant for mostly meant for urban green buildings, urban cities. Okay, and then cities with really good public transport as well. Okay, good question. Any more questions? I've not explained to you the assignment yet. I'll go to the assignment shortly after this. Thank you for asking the question. Okay.
Thank you. Thank you.
Any more questions? I can see Nurin ada member. Who's the other guy?
I'm in the class as well.
All right. Okay. Any more questions? Ada?
I have one.
Yeah, Heather.
Can I ask where to find out how we gonna prove is it the building is very energy efficiency, like besides the calculation and stimulation?
Okay. It's not very easy. Okay. You see, whenever a building goes into a rating exercise, okay, let's say GBI or Green Mark, Green Star, usually the idea behind it by the developer of that building or the owner of the building is to have some kind of branding. Okay, just now I showed you the TNB, no, not the TNB, the Energy Commission's 5-star rating for fridge kan, you know. So for buildings you've got GBI, right? Okay, so whenever you enter a building with a GBI rating, especially really good rating, gold or platinum, the owner of the building will probably put out the plaque that they got from GBI at the front of the building saying that, hey, my building is platinum rated, okay? So it's a branding exercise. But nevertheless, it's a good branding exercise because it shows that the building is energy efficient, the building could be water efficient as well, and then the building could be close to public transport and so on and so forth, you know, based on GBI criteria, okay? But there are thousands and thousands of other buildings out there which are not rated at all, okay? So how would you find out the efficiency of the energy system in that building? The answer is no, you won't be able to find out at all, okay? You see the turkey bed, okay? But you can see some measures being taken by the owner of the building. The easiest one to spot is the lighting system, the artificial lighting. Once you enter the building, you can, if you see some LED lights here and there, no more fluorescent lights, no more incandescent lights, you know for sure that the owner of the building is very, very sensitive towards saving electricity, which is good.
And then also the skylight, is it?
Yeah, having skylights help. Having a lot of windows that you can control, you know, you can open up the windows, you know, let light to come in, you know, let some ventilation to come in, you know. So, and then, you know, if the building owner knows how to manage that, can manage the amount of artificial lighting as opposed to daylighting, then you know for sure that the owner of the building too is very conscious of energy savings. And perhaps, you know, they're on some kind of program, you know, to save energy. But it's good for them anyways, can, you know, because the more they save energy, the less amount of bills they have to pay at the end of the day, right? So they can make more profit. So everything makes sense. Cuma they won't be telling you lah how much they're saving. Okay?
I see.
Because all these commercial entities that they like to keep everything secret.
Okay, thank you.
Right. Good question. Some more? Any more questions? It'd be nice to have some two-way communication going on here.
Afternoon, sir.
Yeah, Young Sen, yeah.
Yeah, just to ask, if we want to calculate the energy efficient for our building, which is 250 meters square, is it the OTTV is not applicable for it? Is it any minimum requirement for the size?
Oh, tak ada sebenarnya, you know. You can apply it on any building for that matter, kan, you know. It doesn't matter lah, you know, even though they might say that, you know, below a certain amount of range or building size, you know, it's not applicable because to them it's just too small, you know. What's the point of calculating? You see what I mean? But you can still use the same methodology to calculate OTTV for a really small building. Boleh, you can do that, no problem, okay. But you get a certain number lah, okay, and the number too will probably might not change that much lah, you know, within a certain range of building size. All right. So no problem. You can do the OTTV calculation on any size of buildings, okay, even though they say no, it's not applicable. But besides OTTV, you can also calculate the BEI, you know, the building energy intensity, okay, or sometimes people call it building energy index. I mentioned the geo building and the zero building just now, you know, both of them running at 65 and 85 kilo hour per meter square per year, which is quite low in comparison to any other offices. And BEI is pretty easy to get. All you need to have are just two information. One is the size of the building, the gross floor area. Okay. Some people argue that no, you just take the net floor area, you take out the car park lah, whatever kind of. But to me, no, you use the gross floor area. You know why? Because even the car park, you still use electricity, right? To run your fans, to run your lights, whatnot. Still electricity there. Okay, so gross floor area, and then also the total amount of electricity a month. Okay, so if you can get that from an energy bill, from electricity bill, then you've got enough information there. All you need to do is simply just get your total floor area, the gross floor area, divide it up by the amount of electricity that you use per month. If you have a monthly data, okay, that number you can multiply by 12, you know, just to estimate for the whole year. If you have the whole year, then you divide it up by the whole year's worth of electricity, and then you get the BEI. Okay, that will tell you how much of electricity that you use in that building, okay, in terms of intensity. So that is a much simpler calculation to get to see
Thanks,
the
sir.
impact. Yeah, and then you can't say whether or not BI is better than OTTV. OTTV is very accurate, which is great. Okay, and then it's tied up to the physicality of your building, which is the size of your walls and your roof, everything, the whole building envelope, which is great. BI on the other hand is just the floor area. Okay, you can argue that it might not. Having said that, the electricity data is very accurate. Okay, so between these two, perhaps if you do calculation for both, lah sebenarnya. Any more questions?
I think I have another question.
Yeah, go ahead.
For our first project of studio, it's on low carbon office. So we are, the expectations are for us to come up with simulations or calculations saying that, like proving our building are low carbon. But they are like certain limitations on the software itself, because some are not free, and even if it's free, it's not really accurate. So what are your advices on these, like what kind of simulations or calculations that we can like do?
Not very straightforward answer. Okay. If you have to do a free kind of technique, is to do a BI calculation lah. Okay. But that BI calculation too is to be based on a projected electricity consumption. Because you don't have a bill, you don't have a bill. It's your own design, isn't it? So if you to project it, then you're gonna have to do a bit of accounting of the kind of electricity consumption that you probably do in your building. For instance, you should be able to sort of identify how many light fittings you have. You should be able to identify how many VRV aircon systems you've got in your building. Or you should be able to identify, how big your central aircon is going to be. You see, the best thing about air conditioning, you can easily open up Daikin website or any other aircon manufacturer's website. They will have all the information about all of their systems, including the performance of their systems. So you could sort of calculate, okay? So if you run your office for about 7 hours per day on that particular aircon system, you probably use out a certain amount of kilowatt hours. Then you multiply lah for the whole month. So you project, okay? With that, you will probably get a total amount of electricity generation, electricity consumption per month, okay? And then you definitely know your gross floor area, kan? So you divide it out. So at the end of the day, you get a BI. That's the very least you can do lah, rather than doing simulation lah, apa kan, I think for a short 2-week or 3-week project tu, a simulation might not be very useful lah sebenarnya. A simulation is perhaps something that if you are to look into the ventilation of your building, or perhaps you want to look into the daylighting of your building, then perhaps you do simulation, okay? If the bottom line is just to reduce the energy consumption and reduce the carbon emission, then just calculate the BI, okay? The other way is not to do accounting or not to do auditing, is to use common configurations, common coefficients that you get. You could find out online, numbers being bandied about. For instance, like for an office, the electricity consumption could be like, let's say 50 kilowatt hours per person per day. If you get that kind of number, a certain number of kilowatt hours per person per day, and then you multiply lah, by the amount of people that you probably have inside your building. Okay, if you have like 100, you multiply 5,000. Okay, so I know 150, yeah lah. 5,000. Okay, so 5,000 kilowatt hour per day, right? Multiply by 30 or multiply by how many office working days lah. With that, you get a ballpark figure kind of thing. Use up your GFA, okay, your gross floor area, and divide it up, you got your BI. Done. Free of charge, isn't it? But you're gonna have to you're gonna have to find out the numbers lah. Okay.
Thank you.
Okay.
Yeah. Any more questions? Siapa lebat?
Ya, baru masuk. Sir, this is not a question tapi just a suggestion.
Yeah.
Regarding the
Yeah.
class,
Okay.
we thought of having the class on Friday morning if it's okay and if you are free in the morning.
Friday morning saya okay.
Boleh ke if we
Right now
push?
ni I don't. Yeah. I'm okay. If you want to change it to Friday morning, even better sebenarnya.
Tak ada
Tapi
tunggu
kalau
sampai petang.
Friday morning, right now ni because my son is not at school, okay, because PKPB, right? But later on, if he goes to school, I have to stop by hook or by crook 11:45, you know, because I have to go and get him at the school. Jadi, you know, if you have to do it in the morning, then the class has to start at 9 o'clock.
Okay.
That's
Is
the only
everyone
drawback
okay?
lah. Kalau petang, if it's afternoon, then we can do 3 o'clock, no problem. You know, we can go until whatever time we want. It's a lot freer. Tapi, you know, if it's in the morning, I have to run it from 9 sharp until about 11:45 tops. Okay. And unless kalau it's I don't know, I think you better vote lah among yourself. I'm pretty open. Okay. So you can come back to me. We will run it in the morning. Hopefully everybody is on board lah.
Okay.
Tak apa lah, take your time. You've got another.
Okay. Thank you, sir.
Any more comments ke, questions ke apa? Yeah. Ada? Tak ada questions? Okay, kalau tak ada, let me share with you put out the assignment on Spectrum later today. Can you see my screen now with the assignment?
Yep.
Nampak tak? Okay, good.
Yes.
There are three deliverables for the course, right? One is the coursework. Technically, they're just diagrams. Okay, it's an essay. Okay, and last but not least is the presentation for the stuff that you did for course and also the essay. All of them group work. Okay, no individual work whatsoever. Okay, but within the group too, you can sort of give tasks to certain people lah. But that one is for your own management. Okay, but for me, all of you are divided up into a certain amount of groups. Okay, so let's go through the assignment, right? So in order to achieve all the learning outcomes, okay, there are 3 learning outcomes as I mentioned earlier. The first learning outcome is tied up to a conceptual design diagram assessment assignment, and then CO number 2 is all about verbal graphic presentation. CO number 3 is aligned with an essay, okay, which must have some figures, diagrams, tables, for proposal. And then the percentage of marks given to each of them. The conceptual diagram 30%, graphic presentation only 10%, the essay 60%. You see, even if you get 100 marks, full marks for essay, you will still not pass the course. You see, if let's say you get 0 for these 2, so you have to pass this. You have to pass this one as well at least in order to pass the whole course. Even if you pass the essay and then you pass the verbal and graphic presentation, you might not still pass the class. So whether you like it or not, you must make sure that you do well in the essay and also do well in the conceptual diagram. Okay, the verbal graphic presentation, if you feel that you do not want to do it at all, ataupun you didn't do anything, and then your friends tell me that you didn't prepare anything for it, and even if you get a 0 mark, but if you did really well the other 2, you should be fine. Okay, so the assessment criteria is as the following on the right hand side here. For conceptual diagrams, all about your idea, the quality of your drawings, okay, and your diagrams, and also the applicability of your idea. Don't just do something which is out of this world that can't be done. It has to be attainable. Okay? So the technology that you want to implement has to be available and cost effective. Okay. And then for the verbal and graphic presentation, the content that you put up, and also the graphics of your slides. Okay. We'll be looking into the format and the references. It has to be properly written according to proper research paper. And then we will be looking into the written content and also the diagrams put up. So instructions, for me, there are 48 of you, okay, in this class. So you'll be breaking yourself up into groups of 6, okay, only 6 persons, no more than 6. With 6, you get 8 groups, okay. The idea is going to be explained to you below here, okay. So in groups of 6, you have to produce a written and illustrated building refurbishment proposal of not less than 4,000 words, okay. 4,000 words is very small lah. In relation to the amount of people that you have in the group, okay. It's just managing the group becomes a bit tricky, but nevertheless only 4,000 words. You can produce more if you want, but let's not make it too wordy lah, right? It is to retrofit the existing in a building, and this is part of faculty project. For our virtual webinar, the dean has already graciously given us a certain amount of budget in greening. Us is to do the assessment, the GBI assessment right now until the end of the semester. Along the way, we'll be come in and look at your rating. Okay. Right now, we have already lined up a talk for your seniors by I think I forgot the name of the company, but this Michael Cheng is a GBI facilitator. Okay, so he'll be talking about GBI, he'll be talking about green building. CK Tang as well. CK Tang is also one of the pioneers when it comes to green buildings. He was involved in the Geo and Zeo buildings that I showed you earlier. Okay, and CK Tang also is an engineer who works closely with architects and look into green buildings. So talks will happen, I think, in the next 2 weeks or 3. Okay, so I'll keep you posted. I really want you to join the talk. It should happen on a Wednesday, and usually on a Wednesday you will not have any classes run. Okay, so hopefully you should be able to join that particular talk, which will be done online. If you can't, we'll record the presentation anyway, so you should be able to watch it offline later. So we'll get Michael Ching and his friends from his place to look at your work, and then we are also lining up people from the person from the building surveying department, and also a QS, to look into the costing of your proposal later on. Okay, so it's a faculty project being mandated by the dean as well. Okay, with the budget to put. So within your report, a few deliverables. Okay, the first one is the assessment. To do the assessment for before and after the alterations that you are proposing. Okay, of the building performance based on the GBI non-residential existing building assessment criteria. Okay, so if you open up the GBI website and then you go to the GBI tools tag, okay, you should be able to find the GBI NREB PDF and then download that, and you should be able to read it, okay, and learn about it from now even. Then you can see there's a lot of criteria in it. There's a number of indicator groups. There's 6 indicator groups, okay, and within the indicator groups there are a few others, smaller ones, right? And then you also to do some calculation of carbon emission before and after alteration. Okay, so before alteration means to say as it is, the mature alam bina with the amount of electricity that is using right now, how much is the carbon emission that is emitting per year. Okay, that one can be calculated very easily. We'll try to get for you the electricity data, and then you can calculate it, right? And then you can tell us, how much you want to carbon lah, right? Tapi, but the carbon emission data here, okay, overall is very easy. Having said that, just now you're dividing up into a number of groups, pertaining to different indicator groups. So, you know, you are to calculate the carbon emission specifically for water alone, let's say, you know, if you can. But otherwise, this one here will become a class-wide kind of calculation, okay? Number 3, the building performance improvement proposal, okay? So you come up with a proposal, you need some precedents, and you have to justify as well why you're doing it that way, okay? And show us some examples. And then you must have some pictures, some tables, some, you know, numbers from precedents as well, okay? And something new for all of you is to do a bit of return of investment analysis, okay? I can show you some examples. So I want you to show us, you know, the improvements that you want to make to the building based on the rating that you got. The amount of money that you invest and the return investment that you probably get at the end of the day. So I'll show you how to do this calculation, and then hopefully you can do that. And then, you know, hopefully the QS that you are roping in can also verify your numbers, okay? Because you want to make sure, you know, that the budget you have is enough. If it's not enough, then we'll have to, okay? And then last but not least, at least 5 conceptual diagrams, design diagrams or drawings to present the conceptual ideas for improving Majalah Bina according to the selected GBRD indicator group. I'm putting some stars here, okay? Because this is actually part of the, you know, the main mission. So 5 conceptual diagrams, okay? There are 6 indicators REB, okay? So students are to undertake study according to the arrangement here. So you've got energy efficiency group, ada 2 groups here. The indoor environmental quality, 2 groups. These 2, I put 2 groups. Why? Because there's a lot more work that need to be done in order to get the rating. So we need 2 groups to, you know, you have to run independently, and then hopefully at the end of the day, we should be able to get some kind of consensus between the 2. Okay, so we get different proposals from each group, which will make it even more interesting. Okay, so the numbers at the end of the day might be similar, but you know, it'd be nice to see some different proposals from 2 different groups for CEE alone, EQ alone. And then one group for sustainable management, material resources, water efficiency, and also innovation. Okay, the submission arrangement, there are 3 parts to the submission. Okay, first of all is the coursework. Just now I marked with a couple of stars here. Okay, so number 5 here is actually the first, at least 5 conceptual design diagram. At least 5 conceptual design diagram and drawings. Okay, so that's part 1 of the course. Part 1, you have to submit that item, and then the assessment is based on ideas, quality drawings, and the applicability. And then you must submit JPEGs, not PDF, not PSD, just JPEGs. Okay, up to 150 dpi per inch at A1 size. Okay, so that we can use this online tool called our board, you know, to do a bit of commenting. Carries 30% of the course grade. Okay, and then the submission is Friday 18th of December, which is a long way from now. Okay, so you should be able to spend some time to really research a little bit about GBI, you know, understanding what kind of stuff that you can do in order to improve the carbon emission, kan, you know, based on, let's say, water efficiency or materials, kan, you know, you can do a lot of things. So that amount of time though, yes, we'll be filling it out with a lot of lectures, but at the same time, you have to do a bit of research on your own. Okay, that's why I'm releasing the assignment early so that you can start early. Submission 18th of December. And then part number 2 is the essay, okay, which is the rest of the deliverables. So the essay ni, you produce it using Microsoft Word. Don't produce it in a different form, okay. Don't use AI lah, whatever lah, you know, just use Microsoft Word. So that you can email it to me, ataupun you can put it up to Drive, and then I can make comments on it, okay. Keep it in Microsoft Word, right. The precedents, and then examples from other projects, and then you must reference it properly and use proper formatting, right? And then this carries 60% of the course grade, which is really, really substantial, okay? And then it's going to be the assessment is based on clarity, rationality, you know, the economic and technological viability of your proposal, you know, the ROI and a few other things lagi lah. Okay, so make sure that the technologies that you want to implement are available in Malaysia. Okay, and then the submission date is next year, which is 15th of January 2021, in week number 13. Okay, and then on the same day that you do the submission, you also do the presentation online. Okay, so this presentation is also a group presentation. Again, 15th of January 2021, week number 13. Each group, you present for about 10 to 15 minutes, and then we have some comments at the end of the day, at the end of your presentation, hopefully all within 20 minutes, okay? This carries 10% of the course grade, okay? So for the presentation, we'll get the other people that I mentioned earlier, the QS, the building surveyor, and also Michael Cheng and his compatriots, okay, to come in and criticize your work. We'll do everything online, and hopefully, the work that you have at that time too is acceptable lah. Okay, so that's pretty much it lah. For the assignment, it's broken down into 3. Any questions for this? I'll put this up into Spectrum afterwards. Any questions? Ada? Clear?
Yes.
Okay, all right, good. So if there's nothing else, then thank you very much for your attention. It's been a long session today. So hopefully I can see you next week lah, okay? Either in the morning ataupun afternoon lah. Okay, you tell me when.
Okay.
So keep us posted. Good luck. Hopefully you have a good weekend, and hopefully you get you should be able to do well in your first project lah for your studio. Okay, thank you, Zati. You can stop recording.
Okay.
Later on, please upload it into a YouTube channel, right?